afternoon, guys. My name is Bamisheli. I'm still the lead tutor for this CSA 206 Human Computer Interaction. In our previous class, we have at least covered some areas. Then, for this particular Unit 4, we are going to delve into more critical environments, whereby that has to do with multi-sensory system, multimodal and multimedia system. We are going to talk about speech, problem in speech recognition. Then at the same time, we are going to talk about speech-related human interaction technology. We are going to talk about sound recognition and gesture, then device for the elderly and disabled. Then we'll be able to conclude after that. So at the end of this, all those areas, it is expected that students should be able to describe a multimodal, multimedia, and multisensory system. They should be able to appreciate the speech and the phonetic typewriter interface. And at the same time, students should be able to understand the earcom and auditory icon as important components of the multimodal system. Then the students should also be able, at the end of the day, to know that recognition and gesture devices are essential for the elderly and disabled. So, introduction. Critical evaluation of the computer-based technology. So the introduction said this unit briefly describes some of the common technology associated with human-computer interactions. These are innovations that improved upon the user interface, particularly those innovations benefiting the disabled. Technology such as the phonetic typewriter, the earcoms, the auditory icons, the recognition and gesture devices for the disabled and elderly are described. So, here, more than one sensory channels are involved in interaction, as in sound, text, hypertext, animation, video, gesture, and visions. So they are used in a range of applications, particularly for users with special need and virtual reality environments. You can see so many innovations has come that many of us are now, even when we are not even disabled, we are using most of those things like eye recognitions, your fingerprints, and the rest of it. And even some of the items will recognize your voice. The moment you say something, the system, since your voice has been programmed with the system, it will be able to recognize it. So the component of multisensory systems are speech, non-speech, sound, handwritten, together with their application and principle. Usable senses. The 5 senses, sight, sound, touch, taste, and smell, are used by us every day. We use our mouth, we use our nose, we use our skin, then we make sound, and we see, we get eyes, we have eyes to see. So we use all these organs for all these purposes. So it is important on its own together. They provide a fuller interaction with natural world. We can ideally utilize the computer to use all the available senses, but this becomes practically impossible because computer really offer such a rich interactions. We can use the sight, sound, and sometimes the touch senses, but we cannot yet use the taste and smell, which is agreeable. So multimodal and multimedia systems, these are more than one senses or mode of interaction, as in virtual and oral senses. For example, A text processor may speak the words as well as echo them to the screen. Multimedia system. These are a number of different media to communicate information. For example, a computer-based teaching system may use video, animation, text, and still images. Different media all using the virtual model interaction. This may also use sound, both speech and non-speech. Of course, two or more media now use different mode. So speech now. Human beings have a great and natural mastery of speech, which makes it difficult to appreciate the complexity, but it is an easy medium for communication. Simple terminology used to describe speech. The structure of speech is called phonemes, and there are 40 of them. The phonemes as basic atomic units that sound slightly different depending on the context they are in. The larger unit of phonemes are the allophones. Allophones are the sound in the language between 120 and 130 and are formed into morphemes. The morphemes are the smallest units of language that have meaning. Prosody is the alteration in tone and quality. There are also variations in emphasis, stress, pauses, and pitches. They impart more meaning to sentences. Co-articulation is the effect of context on the sound. It transforms the phonemes into allophones. Syntax is the term used for the structure of the sentence, while semantic is the collective term used for the meaning of the sentence. You know, I've told you before that syntax is the rule guiding a sentence or forming a speech or writing a program. But it is the semantic that gives meanings to that context. So even as much we understand this, we have a problem. So problem in speech recognition, different people speak differently because accent, intonation, stress, idiom, volume, etc. differ. The syntax of semantically similar sentence may also vary while background noise can interfere. People often hear, but words are not enough. Semantics are also needed. That is, it is not enough to know the rule of construction, because your construction has no meaning if that what you have constructed cannot be interpreted. So you need semantic arrangement which give meanings to the syntax. So then I said it requires intelligence to understand the sentence because context of the utterances often has to be known as well as information about the subject and speaker. For example, even if don't like this is recognized, it is fairly useless piece of information on its own. So speech-related human interaction technology. Phonetics typewriter is developed for Finnish, a phonetic language. This machine trained on one speaker will generalize the training to others. A neural network is trained to cluster together similar sounds, which are then labeled with the corresponding characters. When recognizing speech, the sound uttered are allocated to the process corresponding output, and the character for that output is printed. It requires a large dictionary of minors variations to correct generalize general mechanism. So you can see the example of phonetic typewriter. Then the usefulness of speech recognition. So what 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 it is useful for a single user or in a situation in which limited vocabulary system exists. For example, in a computer dictations, in the public and open places of limited vocabulary system, it can work satisfactorily, e.g., in some voice-activated telephone system. For the general user with wide vocabulary system, problems do occur. It is great potential value, however, manifest when user hands are already occupied, as in driving or doing manufacturing, particularly for users with physical disability. Another advantage is lightweight and its use as a mobile device. Then this is a generation of speech. It is useful because of its natural and familiar way of receiving information. It is also useful in a certain constrained applications when the user has few alternatives and is particularly motivated to overcome problem. However, it has its own problem, similar to speech recognition, particularly in prosody. Additional problem can arise when intrusion causing the need for headphone, particularly due to noise in the workplace. It transcends nature. It's a problem when it becomes harder to review and browse. Few examples occur in screen reader that read the texture displays to the user, e.g., as utilized by virtually impaired people. Also, in warning signal, spoken information, sometimes presented to pilot who speak. Sound. For example, now let's take sound for example. Sound. Non-sound speech. These are bong, bang, squeak, click, etc. that are commonly used for warning and alarm. Fewer typing mistakes occur here with key click. It is also useful in video games that become uninteresting without sound. Unlike speech, it is language and culture independent. Non-speech sounds provide dual mode display in information presented along two different sensory channels. It provides redundant presentation of information in resolution of the ambiguity in one mode through information in another. It is good for providing both transient and background status information, e.g., sound can be used as a redundant mode in the Apple Macintosh. Also, almost any user action, file selection, window active, disk insert, search error, copy complete, etc., can have a different sound associated with it. Auditory icon. So, auditory icon this is used natural sound to represent different type of objects or action. Natural sound have associated semantic, which can be mapped onto similar meaning in the interaction, e.g., throwing something away, such as the sound of smashing glass. Problems sometimes arise because not all the things have associated meaning. Additional information can also be presented on morphing sound if object is obscured. Action is in the background. This use of stereo allow position information to be added. An example, we have Sonic Finder for the Macintosh. Here, item and action on the desktop and moving file produce a dragging associated sound. For example, folders have a peppy noise sound. Copying sound gives a sound of a leak progress of the copy. Big files have a louder sound than small. Then we have also aircon. There are synthetic sound used to convey information. Pour into respectable while rising pitch indicates the lead ones. The comprises structure the combination of notes or motifs that represent actions and objects. Motifs are combined to provide rich information. Compound aircom are multiple motifs combined to make one more complicated aircom. So this image is for the aircom. Then the family of aircoms. Here, similar type of aircoms represent similar classes of actions or similar objects. The family of errors would contain syntax and operating system errors. Aircoms are easily grouped and refined due to compositional and hierarchical nature. It is harder to associate with the interface task since there is no natural mapping. Touch recognition comprises 1. Haptic interaction made up of continuous perception that provide tactile sensation and vibration on the skin. 2. Kinetic comprising movement and position and force feedback. Touch recognition also includes information on shape, texture, resistance, and temperature, and comparative spatial factors. Example of technology on touch recognition include electronic braille display and force feedback devices, e.g. phantom that recognize resistance and texture. Then we also have handwritten recognition. Handwritten is another communication mechanism which we are used to in day-to-day life. The technology of handwritten consists of complex strokes and space. The handwritten is captured by digitized tablets through stroke transformed to sequence of dots. Large tablets available are suitable for digitizing maps and technical drawing. Smaller devices, some incorporating thin screen, are used to display the information such as including PDAs, Palm Pilot, and tablet species. The problem associated with handwritten recognition are personal difference in letter formation and co-articulation effect. Then gesture technology. This can be found in its various applications such as gestural inputs, e.g. PUDA and sign language. The technology comprises data glove and position sensing devices such as MIT Media Room. Gesture provides the benefit or natural form of interaction by pointing. It enhances communication between signing then device for elderly and disabled. We have visual impairment, use of screen reader and sonic finder, hearing impairment, use of text communication and gesture and capture. Then we have physical impairment, use of speech input and output, eye gaze gesture predictive system. Then speech impairment, use of speech synthesis and text communication. Then let's say use of speech input and output. Autism, use of communication and education devices. Older people use disability aid, memory aids, and communication tools to prevent social isolation. Then others, children use appropriate input and output devices for education, games, and fun. In solving cultural differences, the influence of nationality, generation, gender, race, sexuality, class, religions, political persuasion, etc., are affected by the interpretation of the interface feature, e.g., interpretation and acceptability of language, cultural symbols, gesture, and color. Okay? With this, we have come to the end of this unit. And the conclusion says, since the basic goal of human-computer interaction is to study is to improve the interaction between users and computers by making computers more usable and receptive to the user need. There is continuous research in human-computer interaction that involves exploring easier to learn or more efficient interaction techniques for common computing tasks. These include inventing new techniques and comparing existing techniques using scientific method. In summary, uncommon technology associated with human-computer interaction include consideration of the multimedia and multimedia system. Let me take that again. Consideration of the multimodal and multimedia system that incorporates speech recognition and synthesis, the phonetic typewriter sound interface facilities, recognition and gesture mechanism. These facilities particularly aid the elderly and disabled to effectively and comfortably interact with the computer system. We have come to the end of this class today, so hope to see you in another class. Thanks for listening and have a great day.